All right, in this last video for systems with 3 variables, we're doing applications or word problems specifically for these 3 variable systems. With these, or in this lesson specifically, I'm not going to solve the entire system. I'm really just going to set it up because we have learned how to do the solving process. And we learned with 2 variable system applications how to write our solution in terms of the context that was given in the problem. So for number 1, Billy's restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came out to $589.50. How many of each type of flower was ordered? So one of the equations is going to deal with this 200 flowers. If we put all of the flowers together, we should get 200. We do need to define our variables. You can let this be x, y, z if you want. In this case, x would equal the number of carnations sold. Or at least that's what I'm going to let x be equal to. And y is going to be the number of roses sold. And z would be the number of daisies. We take these and we set up our equation. So if I have 200 flowers, all of the carnations plus all the roses plus all the daisies should equal 200. We can set that up as x plus y plus z equals 200. Then we also had a total for the amount of money, $589.50. If I get $1.50 for each carnation, that expression would say $1.50x plus $5.75 for every y and plus $2.60 for every z should come out to a total of $589.50. Now we still have 3 variables, which means I need 3 equations. The last one is coming from this 20 fewer roses than daisies. We need an expression that's going to explain how many that is. So that could say that R is equal to D minus 20. The number of roses is equal to however many daisies we had minus 20. That would tell me that there are less roses than daisies. So another way you could have written that as D is equal to R plus 20. If there are 20 fewer roses, then that means there are 20 more daisies than there are roses. So either one conveys the exact same thing. It doesn't really matter. We just need to express that in terms of the variables that we had. So I'm going to rewrite this back with x's and z's here, just to match what we had previously said. So our roses, y is equal to the daisies, z, minus 20. Or you could say that z is equal to y plus 20. Either way, that gives us 3 equations in my system of equations. You could solve this with substitution because I know that y is equal to z minus 20. I could take that y and substitute, or I could take that z minus 20 and substitute in place of y here. And that would give me a 2 variable system with only x's and z's. Either way, we've set up our 3 equations and we would get our 3 solutions. For number 2, the Arcadium Arcade in Lynchburg, Tennessee uses 3 different colored tokens for their game machines. For $20, you can purchase any of the following mixtures of tokens, where we have 14 gold, 20 silver, and 24 bronze, or 20 gold, 15 silver, and 19 bronze, or 30 gold, 5 silver, and 13 bronze. We want to know what is the monetary value of each token. All right, so I'm going to say G is the value of the gold tokens. We want to be specific about what our variable stands for. If you just say G equals gold, then that's not explaining what does that actually represent. Does that mean the number of gold tokens? Does that mean the weight of the gold? Does that mean the price of the gold? I don't know, so we want to be specific about what we have. So we don't write just something like G equals gold. Because I do have many variables, if you've written this out once, you can kind of use some shorthand. So I can say this is the number of silver tokens, and B is the value of bronze tokens. Then we set up our equations. We know that for $20, I can get any of these combinations. So one combination would be 14 gold plus 20 silver plus 24 bronze equals $20 worth of tokens. Again, you could do 20 gold plus 15 silver plus 19 bronze is still equal to $20 worth. And lastly, we've got 30 gold plus 5 silver plus 13 bronze is equal to 20. We have a 3-variable system. We would solve that 3-variable system the same way we have the others. All right, for number 3, last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Now, tickets can be bought in one of 3 ways: a matinee admission that costs $5, student admission, which is $6 all day, and regular admission tickets are $8.50. How many of each type of ticket was sold if twice as many student tickets were sold as matinee tickets? So we can let's say we have matinee M. So this is going to be the number of matinee tickets sold. We can do S for the student tickets. S is equal to the number of student tickets sold. And then we have our regular admission. I'm going to do R is equal to the number of regular tickets sold. And we'll set up our equations. Since we know there are a total of 8,500 movie tickets, M plus S plus R should equal 8,500. We also know the prices, so we get $5 for every matinee ticket sold, plus $6 for every student ticket sold, plus $8.50 for every regular ticket sold. That would give me a total of $64,600. The last equation's coming from the last sentence here. So how many of each type of ticket was sold if twice as many student tickets were sold as matinee? That would mean that the number of student tickets, S, is equal to twice as many matinee. So S is equal to 2M. That's our third equation, S equals 2M. You can use that to substitute. We could take 2M and put it in place of each S and get a system with only M's and R's. and that would be our two variable system. All right, we've got one more down here, number 4. It says, Mabry invests $50,000 in a money market account at 3 different banks. Bank A pays 3% interest per year. Bank B pays 2.6% interest, and Bank C pays 4% interest. She decides to invest twice as much in Bank A as Bank C. And after 1 year, Clarice, this is a typo, that should be the same person. So after 1 year, Mabry has earned $1,533.28 in interest. So we're going to set up 3 equations. And I'm going to let A be the amount invested in Bank A, B is going to be the amount invested in Bank B, and C is the amount invested in Bank C. Since we invested $50,000, if I take each amount, A plus B plus C, it should equal $50,000. We also know that we are gaining interest. We gained a total of $1,533.28 in interest. So if I put the interest equation there, I get 3% interest for everything in Bank A. That's 0.03 times the amount of A, plus 0.026 times the amount in Bank C, and plus 0.04 times the amount in C, should equal $1,533.28. That's our interest equation. Lastly, we had a third equation that uses this information that says she decides to invest twice as much in Bank A as Bank C. So the amount in Bank A is double the amount in C. It's twice as much as C. A is equal to 2C. Again, we could use substitution and substitute that into A's, and then we would have a 2-variable system with only B's and C. So you can take that and solve each of those systems, then put your answer in context of the variables that we defined.